Linked list using Python. So linked list is a collection of nodes, is a collection of nodes. And if you take a node, because it has to have links to the subsequent nodes, so there will be data part and there will be link to the next node. And this link is actually a reference in Python. If I take Python, the link to subsequent nodes we can have only through reference. So when you take a linked list, there will be a node, several nodes. There will be several nodes, and one node is referring to the other node, subsequent node. And this is how the linked list is represented in memory. Now, normally when we take this linked list, there will be some reference to the first node. Reference to the first node. The first node generally we give the name as start. This is how the representation of linked list is made. So there will be series of nodes and every node has data and link. For example, this may be 10 and it has reference to the next node, 20 reference to the next node, 30 reference to the next node. Finally, there will be the last node will not have any subsequent nodes. So the link part is represented with none. None indicates that there are no further nodes present. So when the linked list is represented like this in memory, to access it, there should be some starting point or reference to the first node that will be represented with the help of a variable called start. You can give any name. Generally, we give the name start. Start holds reference to the first node. Once you have reference to the first node, because every node has reference to the subsequent nodes, we can run through all the nodes. This is the requirement. So this is how the linked list is represented. Now in Python, if you want to represent linked list, as I told you, everything in Python linked list node, everything is represented with the help of a class. So we'll take a class called node. And this node has one constructor to attach the attributes. So the constructor in Python is represented with init. So there will be self always referring to the current object. So self dot data will be represented here. I'll take some data. So self dot data equals to data. Data is passed, and self dot next. Self dot next equals to none. Initially, I create a node with none so that whenever we require a reference, we can attach it. This is how the node should be created. So a node in Python is created with just a simple constructor where data is passed and the link part will be none. So here I am writing the link part as next. I can write whatever it is. So I can write next or link. Here I am writing the reference name as next. It is up to us to use appropriate name. Now when I take the linked list, so we'll have a linked list with class linked list. So there will be linked list, and this linked list will have the starting point, which is actually the start. So self dot start, to start with. The linked list will be empty. So when I take the linked list, because this is existing linked list, when list is empty, start will be holding null to none to indicate that there is no node in the linked list. So this indicates that linked list is empty. Indicates that linked list is empty. Is empty. So this is how I have to create. I am creating one constructor with the constructor with self. Only one method, which is constructor with the start reference, which will be none. So I add the subsequent methods here. So required methods are added here. Required methods are added here. So this is the linked list. Just I have given the constructor and I have created node class and I have created linked list class with only constructors. Node class will not have any other method. In linked list will be doing the other methods which I'm going to give now. Now, when you take this linked list, this is the simple representation of linked list. Now, when I take the linked list will have several operations to do. Any data structure, generally the operations are common. So the operations on linked list, if you take, so the operations on linked list, so there are several operations. One is insert. This insert I can do in different ways. Insert at beginning of the linked list. Insert at end. Insert after given node. Then delete a node after given node. So delete a node. Uh, then the other option is um, uh, trans, transaction, traversal. So traversal is generally visiting each and every node, and generally here we use display. So traversal is nothing but the technique to visit each and every node to do some processing, and the processing we do is display, and these are the operations we do. So these operations what we do is we do with the help of a menu driven program. So to perform these operations, I'll write a menu driven program function. So I'll write a menu driven function here and I'll write it as a main, a function main. So generally the menu driven is with while loop. So I'll take while true. So what I'll do is I'll I'll display the options. So the options are print menu, print first option, this actually menu. Then I'll say one insert at beginning, print to insert at end, print insert after a given node, then delete a node, print 5, uh, display. Here it is traversal or display, whatever name we want to give, we can give. Then finally, this is uh, exit. Sixth is exit. Now it is a menu driven program. So I'll read the option, print, I'll say option equals to int input, enter your option. So if option equals to 6 brick, remaining options will be doing. This is how we write menu driven program. So I want to give the overall picture, then I'll be giving each operation separately. Then finally I'll call main. So I'll call main and execute this. So because I have not added anything, it does nothing for any option. Only when I say 6, it is going to terminate. So this is the simple logic of the program, and this is overall picture of linked list, how it is going to be, and we'll be learning each one separately.